Let's see how we can take a graph that has already been created and find what the equation would be in slope-intercept form. So, as you know, in order to write an equation in slope-intercept form, the two things that we need are the slope and the y-intercept. So those are the two pieces of information that we're hunting for. And the y-intercept, of course, is the easiest to find. All we do is we look at the y-axis and we say, where on the y-axis does this line intersect? And here it's pretty obvious right here. This is the y-intercept. So that's going to be our value of b, and the y-intercept here is 1. So our value of b is going to be 1 because the y-intercept's at 0, 1. Now we need to find the slope. Slope is rise over run, and so of course to find rise over run, we need 2 points. We have to have 2 points to count the rise over run between. And so we can use any 2 points that we want, but there's some points that are easier than others. So for example, using the y-intercept as one of our points is pretty smart, right? We've already got that 1 point, why not use it? Let me show you an example of a bad point to use. I could use this point. It would be okay for me to use that point to count rise over run, but that would be a bad choice. And hopefully you can see why that would be a bad choice. Although it would be easy for me to count the run, it's just over 1, it'd be really hard for me to count the rise. How much am I going down? Since that point that I selected is not exactly on the intersection of the graph, it'd be hard for me to say exactly what the run is. So that'd be a bad point for me to choose. Likewise, this would be an even worse point. I could use that point. That would be an incredibly bad point to use because now I can't tell the rise or the run exactly. I'd have to estimate the rise or run there. So although you can use those points, those are pretty bad points to choose. What I'm looking for in my second point is something that is exactly on the intersection of the graph because those are going to be whole number points and very easy to count. And of course, now you can see I've got two great candidates. This would be a really good point because that is exactly on the intersection. And this would also be a really good point because that's on the intersection. It doesn't matter which one that we pick. I'm going to use just this one on the right side there. So it looks like we're going down 1 and over 1, 2, 3. So our rise is -1 and our run is 3. It's important to get the rise correct. The line is going down, so we're going to have a negative slope. So a rise of negative run, the rise of -1, and a run of 3. Okay, so that means our m, which is rise over run, is going to be -1/3. So when we write our equation in slope-intercept form, we do y equals mx plus b. We're going to replace the m with -1/3. So let's erase the m there and put our -1/3. And our b is going to be replaced with 1. And that is our equation in slope-intercept form. Y equals -1/3 x plus 1. We only need two pieces of information, the y-intercept and the slope. Once we have those, we can write the equation in slope-intercept form.